This is section 3.3 on Pythagoras estimating square roots of numbers. The first question says, explain how to estimate the square root of 28 to one decimal place without using a calculator. So the answer for this is, and the method that we use is we create a number line. And the square root of 28 will be greater than the square root of 25, but it'll be less than the square root of 36. And the reason why I chose 25 and 36 is because those are the first and last numbers that the square root of 28 will fit between that are perfect squares. And some people are like, well, what are all the perfect squares? Well, 1 is a perfect square, 4, 9, 16, 25, 36, 49, 64, 81, 100 are the first 10. 121, 144, 169, 196, 225, 256, 289, 324, 361, and 400. And the reason why I know all these is because they are simply the multiples of a number by itself. So for example, 144 is a perfect square because it is the multiple of 12 times 12, and therefore it is the 12th number on this list. 289, which is right here, is the 17th number on the list, and therefore it is 17 times 17. So at the very first of the unit, I told you what the first 20 perfect squares were, and you copied them down in your notes. And they're on the wall as well, so if you needed to know what they are, they're always there. But these are the first ones. So when I looked at the square root of 28, I realized that the square root of 28 falls between this one and this one. So therefore I use it as my bookend. So I'm going to put the square root of 25 here, and the square root of 36 here, which the square root of 28 falls between. The square root of 25 is 5, and the square root of 36 is 6. So I know right now that the square root of 28 is 5 decimal something. It would probably be about there on a number line, because it's closer to the square root of 25 than it is to 36, maybe even a little closer. And therefore I would estimate that the square root of 28 is maybe 5.3 or so. So I'm going to put ISH at the end for 5.3ish. Just to double check, I'm going to take my calculator and ask what is the square root of that, and it is 5.3. So I was able to get the square root of 28 without using a calculator and simply making a number line and placing it between two perfect squares that I do know. Question 2 says, find a whole number that has a square root between 3 and 4. So again, if I was to write square root between 3 and 4, so its square root is 3 and 4. So therefore, the square root of 9 is 3, and the square root of 16 is 4. So the square roots of 3 decimal something. Another way to rewrite it, and in fact, if I was making the textbook, I would have written it, find a whole number that has a square root of 3 decimal something. Instead of saying between 3 and 4, I'd rather say square root of 3 decimal something. So if 9 has a square root of exactly 3, we know that the square root of 10 would be the first whole number that has a 3 decimal something. Square root of 11, square root of 12, square root of 13, square root of 14, and the square root of 15 would also be numbers that would approximately have square roots of 3 decimal something. So how many whole numbers are there that have a square root of 3 decimal something? Well, if I take my highlighter, I got 1, I got 2, I got 3, 4, 5. There are 6 whole numbers whose square root is 3 decimal something. You cannot include 9 and you can't include 16 because its square root is exactly 3 and its square root is not between it but exactly 4. So the answer for this one is there are 6 of them and you can choose any of those 6 numbers. Question 3 says Jason is doing his math homework and he has to find the square root of 10. He presses square root of 10 on his calculator and the screen displays 3.16227766. However, when 3.16227766 is multiplied by itself, the answer is not 10. Why is that? Well, because the square root of 10 is not a perfect square. And therefore, if I was to use my calculator, which is a little bit bigger than Jason's, and I was to put the square root of 10 put 10 and then second function square root, I get a lot more decimal places than he did. Right? He stopped at the 6. And in fact, this decimal place right here, 7, would continue on forever and ever. It's an infinite, non-repeating, non-terminating decimal. So because he stopped at here, right, he stopped at the 6, that multiplied by itself is not as close to 10 as if I took this one and multiplied by it 10, or multiplied by itself. Because if I multiply that by itself, it gets even closer to 10. And if I was to have a bigger calculator that was able to put that many digits, I would actually multiply together to get a number even closer to 10. But no matter how big my repeating decimal is, when I multiply that repeating decimal by itself, it doesn't give you 10. It gives you a number closer and closer and closer and closer to 10, but not 10 itself. So when he did it, and he did 3.16227766 multiplied by itself, he got something that was close to 10, but not quite 10. And again, the more decimal places you add, you don't get 10, but you get closer to 10. Question 4 says estimate the square root of each number to one decimal place, then check with the calculator. So all of these require a number line. And if we go back to what are the perfect squares, I'll go back to this one right here. What are the perfect squares that 72 would be between? Since I've already written it here, 72 would be between 64 and 81. So when I go back to this, I would put the square root, oh, that's not the one I want to use. I'd put the square root of 64 here, and the square root of 81 here, because that's where the square root of 72 would be between. This is 8 and this is 9. So I know the square root of 72 is going to be approximately equal to 8 decimal something. And if I use the number line, I could say it's probably close to the middle. So probably 8.4 or 8.5-ish. I'm not sure. But any of those answers are fine. 8.4, 8.5, even 8.6 is fine because you didn't have to do much thinking there. But 8.4 is just probably your best guess. Your next one, square root of 103, will fit nicely between the square root of 100, which is 10. And somebody asked me, how do I know what the next one is? Well, since 10 times 10 was 100, if you don't know what the next one is, you know it's going to be 11 because that's the next whole number. And 11 times 11 in the calculator is 121. So we know that the square root of 103 will fit between there. So it's 10 decimal something. Or to be more precise, it's probably close to there. So maybe 10.1 or so. Something like that would be a good estimation. And finally, the square root of 55 fits between the square root of 49, which is 7, and the next one, which is the square root of 64, which is 8. It seems to me that the square root of 55 is slightly closer to the square root of 49. So a good guess would be probably 7.4 or 7.3. I'm going to leave those on there. Now I'm going to take my calculator to check my answers, see how well I did. First one is the square root of 72. I said 8.4, and the answer is 8.5. Not bad. Second one was the square root of 103. I said 8.1 or so, and it is 8.1, or 10.1, which is good. And finally, the square root of 55. I said 7.4, and it is 7.4. The next question is question 6. It says, what is an example of a number that has a square root between 8 and 9? Another way to read this would be 9 decimal something. What's a whole number that has a square root of 9 decimal something? Well, we know that the first whole number that has a square root of exactly 9 is 81. So therefore, the first whole number that has a square root of 9 decimal something would be 82. And that would be their first one. It's 9 decimal, probably 1-ish or so. And since the next one over here would be the square root of 100, which has a square root of 10, the last whole number that has a square root of 9 decimal something would be what? What's the last whole number that has a square root of 9 decimal something? Amavir? 99. So the square root of 99 would be the last whole number that has a square root of 9 decimal something. And in between here, there would be all the whole numbers between 82 and 99 that would have a square root of 9 decimal something. Any of those would be right. Square root of 82, square root of 83, square root of 90, all of them have square roots of 9 decimal something. Question 7 says identify a whole number with a square root between 11 and 12. Same question. So what is the first whole number that has a square root of 11 decimal something? Square root of 122. Square root of 122 is the first whole number. And what would the last whole number be that has a square root of 11 decimal something? Right here. What's the last whole number who has a square root of 11 decimal something? Square root of what? Say it again. Right, the square root of 143. Square root of 143 would be the last number. So any number between 122 and 143, any of those whole numbers would have square roots of 11 decimal something, or a square root between 11 and 12. Question 8 says identify all the possible whole numbers with a square root larger than 2 and smaller than 3. So the square root of 4 gave us that square root of 2. The square root of 9 gave us that square root of 3. So all of the possibilities would be the square root of 5, the square root of 6, the square root of 7, and the square root of 8. There are 4 possibilities. Those 4 square roots will all give us square roots larger than 2 and smaller than 8. And I can just take one of them, square root of 7. Square root of that is 2.64. Square root of 8, 2.82. Square root of 6, 2.4. And finally, the square root of 5 is 2.2. Question 9, what are all the possible whole numbers that have square roots between 4 and 5? A lot of redundancy in these questions, isn't there? So, what numbers have square roots of 4 and 5? 25 and? Sorry, not 25. Oops. 16 and 25. So all the possible ones would be, I'll use a different, let's use pink because it's such a pretty color. Square root of 17, square root of 18, square root of 19, square root of 20, square root of 21, square root of 22, square root of 23, and finally the square root of 24. All of those will have square roots between 4 and 5, which means there are 1, 2, 3, 4, 5, 6, 7, 8 whole number whose square root is between 4 and 5, or another way to say it, of 4 decimal something. This square has an area of 20 centimeters square. Estimate the side length. So the square root of 20 is approximately, using my number line in the middle, which would mean it's probably about 4.5 centimeters or so, approximately. So your last question in your sheet says, question 12, while shopping online, Ji-hyun finds a square rug with an area of 11 square meters. He needs to know if it's going to fit into his bedroom, which is 4 meters by 5 meters. Estimate the side length of the rug. So if I was to draw the square rug, and inside put 11 meters squared, even if you're great at math and even if you know exactly what you're doing, because this is a story problem, an expectation that I have as your teacher, and most teachers would, is that you would first try to draw it if possible. So the first thing I do is draw that rug. And since I know it's 11 meters squared, the side length, area equals side squared. Since the area is 11 meters squared, then side squared will equal 11. So back to 3.1 when we did squares. If the area is 11, then side squared will equal 11. And keeping in mind the algebra idea, whatever you do to one side, if I square root this side and I square root this side, it's equal. So if I square root 11 and I square root side squared, the square root of side squared is side, and the square root of 11 should be slightly greater than 3, which is 3.3. So now that we know it's 3.316, we're going to roughly estimate it's going to be roughly 3.3 by 3.3. And again, because 11 is not a perfect square, and I've estimated it to be 3.3, if I actually multiply 3.3 by 3.3, I only get 10.89, which is not 11, because again, 11 is not a perfect square, but it's pretty close. And if I was to keep more decimal places, that 10.89 would get closer and closer and closer to 11, but it would never be 11. It would just be closer to 11. We'd finally get it down to like 10.9999999999999, maybe 873, which is pretty close, but not 11. So therefore, we know the side length is approximately 3.3 meters. And if I know that his bedroom, which I'm going to draw again, is 4 meters by 5 meters, a rug that has a side length of 3.3 meters would fit into his room. So yes, it will fit because it's only 3.3 meters. And in fact, he would have 0.7 meters left on one wall.